Hello ladies and gentlemen, and welcome back. Root Beer here with more of the 2000 Cayley paper. We're just starting part C, so the questions are worth 8 marks as opposed to 6 and 5 that we had earlier. We're on to question number 21, the very first question in part C. Okay, now I think, if we just take a look at these three, we have 24 and 25 on the next page, but 21, 22, and 22, this should be 23. These are actually these are actually questions that appear on other versions of the contest. The Pascal, Cayley, and Fermat are all written together by sort of the same committee at Waterloo, and so you will often get overlapping questions. So if you don't like an explanation I give for this 21, I think it's on the Fermat. You can go take a look at my explanation in that video as well. Same with this ant. I think he might be on the Fermat as well. I think this last question, which is listed as 22 but should be 23, I think this might be on all three papers. So, just a little word of advice, or warning, I guess, maybe, for the next 3 videos. You can find other copies of them, and maybe I give other explanations in those videos that you might find more suitable. Although I like to think I'm consistent. Anyway, that's enough the sort of jibba-jabba. Let's talk about question number 21. A wooden rectangular prism has dimensions 4 by 5 by 6. This solid is painted green and then cut into 1 by 1 by 1 cubes. So it'll be 4 by 5 by 6, so 4 times 5 times 6, that's 120. We'll have 120 1 by 1 cubes. Okay. The ratio of the number of cubes with exactly 2 green faces to the number of cubes with exactly 3 green faces is... Alright. So, with a question like this, these numbers aren't that big. I mean, if it was something like a 10 by 12 by 36 or something, I would say look at some smaller cases. But with 4, 5, and 6, I think we can just draw a picture here. But, of course, we need a brand new sheet of paper. So let's take a look. This is actually turning out to be a really good rectangular prism. And now I have to sort of split it up and do a 4 by 5 by 6. So I've made this side a little longer, so I'm going to say this is my 6. So if I want to draw 6, well, 6 is divisible by 2. So what I'm going to immediately do is split this side in half. And split this in half. And once I do that, then I split the remaining sides into their 3s. Well, it started out as a good rectangular prism, but not going so well now. Alright, now these sides actually I sort of drew it as a square, so let's just pick, we'll say the vertical one is going to be 4. 4 divisible by 2, so I cut it in half, and then we have to break this into 2, so we cut it in half again. Now the 5 is always a little tricky, so sort of put a column in the middle, and then split those into halves. Alright. Connect everything up so it looks nice and neat and proper. Alright, so there is our cube, and it's cut. We're showing where the cuts are going to be. Kind of looks like an oddball Rubik's Cube or something. And so the sides are painted green. If I were doing this contest, I probably wouldn't have filled the whole thing in, but I have the time, and you can, of course, fast forward through this if you want. But I'm going to make the whole thing look green right now. So we can really get a sense of what's going on with this question. Now, we're asked about pieces that have exactly 2 faces green and 3 faces green. Okay. Well, if 2 of your faces are green, the cube must lie on 2 faces of the rectangular prism. Well, what sort of cubes lie on exactly 2 faces? Exactly the edge pieces. So we need to figure out how many edge pieces there are. Okay. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is probably going to take a while. So we have to ask ourselves, where do we get edge pieces? Well, on the edges. And the edges have length 4, 5, and 6. Each edge has 2 corner pieces, and the corner pieces are exactly those that lie on 3 faces. 3 faces. Green, that means you're looking at a corner piece. So we don't count corner pieces when we're counting up how many pieces have 2 edge faces. So 4 cubes on the 4 edge, the edge of length 4, but we subtract off the 2 corner pieces. So there's going to be 2, 3, and 4 two green face pieces. So now the question is, how many edges of length 4? Four edges of length 5 and 4 edges of length 6. Therefore, they're going to be 4 times 2 plus 4 times 3 plus 4 times 4, which is 36 edge pieces. Okay, so that's one of the things we needed. We needed all the faces with 2 green faces, and we counted them up. So there'll be some here and here and here, and also on the back, the side of the prism that we can't see. Now, only the corner pieces have 3 green faces, and there are 8 of them. Okay, this isn't hard. Just think of a cube. It's got exactly 8 corners. So 1, 2, 3, 4 of these, and then there'll be 4 at the back. And we want the ratio, right? Ratio, not fraction, of pieces with 2 green faces, 2 pieces with 3 green faces. So that's 36 to 8. but each of these has a factor of 4 in them. So we can take out that common factor, and we're going to be left with 9 to 2. And I think that was A, or was that B? No, B is 9 to 4, A is 9 to 2. Alright. So we would circle or bubble in A. Alright, so I don't need to rewrite that. I already anticipated that, and I wrote in my A. Okay. So that was question 21. Like I said, I think it's on a Fermat, so you can go see how I did it when I did that video. And join me for a question about an ant in the next video as we look at the first question 22 on the paper.